but I do need help during the live coding.
Fine.
Yeah, so, well,
I still need to learn from.
welcome everyone. Thank you for coming to the meetup. I'm going to introduce you Cosmos and what Cosmos is, what the vision behind Cosmos is, and how Cosmos fits into the current ecosystem of blockchains. It'd be great, so if everyone could use your phones and go to this URL, so that you can submit questions there, because this session is quite long, and we will have breaks in the middle, where you can think about questions you might have, and then we can talk about them later on, after the entire thing is over. And it's literally just enter Cosmos, and you should be able to submit questions. Yes, so today I want to talk to you about how Cosmos is the next natural evolution within the blockchain space. Recently we've come up against a lot of problems, right? So we have the scalability issue with Ethereum and Bitcoin, with hard fork of Bitcoin recently happening. And we have the whole issue around the fact that we're building these immense silos. We're building these stores of value which are completely isolated from everything else. It can be kind of seen, and I'll use this analogy later as well, the early days of the internet, where a lot of services were isolated in their own networks and you couldn't really interoperate between the different services. And that's kind of the stage we're in right now with blockchains. But the next evolution will be that we actually have full interoperability between different services. And of course the holy grail. Okay, cool, yes. This talk will be split into 3 different parts. The first one will be a demo. The second part will be a high-level overview of what Cosmos is and how it works from an architectural perspective. And the third part will be more of a deep dive into how it actually works under the hood, how you as developers can make use of it, how you can build applications on top of Cosmos. And yeah, that should be it. And then we'll have a Q&A afterwards, because I hope there will be questions. I'm actually pretty certain that there will be questions, because
There are already a lot of questions.
oh, great, cool. So let's get started. So that's me. I have a background in computer science and business management. And this is just so to get you started, that you know a little bit about myself. I've lived in 4 different countries, and I'm an avid drone enthusiast, so I fly small racing drones on the weekend. By far the coolest thing I've discovered last year, besides blockchain, I think. My research interests within the blockchain space are very much around consensus engines and secure peg zones. So secure peg zones are all about how do you actually move value that you have in one of these silos and port it over in a secure way to another silo, or ideally not a silo at that stage. But not only the one-way peg, but rather the two-way peg. So how can I move one Bitcoin into Ethereum and then again from Ethereum back into Bitcoin? And with that comes also decentralized exchanges. And I think one of the more interesting things is e-voting and usability, because I wrote my master thesis on e-voting. And I think the usability question of blockchains is a real problem at the moment, right? We need to get to a stage where not only technical people are able to use blockchains, but rather where the experience is so easy that even my parents or my grandparents are able to use it. Oh yeah, and I want to introduce also the team behind Cosmos. So we're roughly 10 to 15 people, and this is really out of date by now, because we're always adding more people. But yeah, this is kind of the core team that's been developing Cosmos for the last 2 years or so, and I've recently joined. So, demo time. Harriet, if I could ask for your help to hold the microphone.
Yeah, of course.
So this is the first time I actually do a live demo, but it should give you kind of an overview of what the possibilities actually are and how easy it is to get started with, especially the Tendermint consensus engine. So you should be able to, normally you should be able to, within, let's say, 10 minutes, be able to get your first application running. And that doesn't sound really great, because as you can see, we're going to do a very, very simple application. But you always need to remember that this application can run on tens of thousands of computers at the same time, and the core consensus engine can actually maintain the order of transactions. So you can have tens of thousands of users around the world all submitting transactions at the same time, and you never run into conflicts from the application side. Let's see where we are. Okay. I've tried this before, so I'm just going to remove the old files and recreate them. Okay, so we're starting from a clean slate. I've recently added the ability to install Tendermint, the core consensus engine, which we'll talk about a lot later, from Brew. So if you're on Mac, you might be familiar with the Brew package manager. So the only two steps to actually get started with Tendermint are Brew tab Tendermint, which installs the formula to, and I'm not going to run this might take a while because I don't have great network here. And then you go Brew install Tendermint. And again, I can't run this because it takes forever to run over the Wi-Fi. There we go. But those are the only two steps to actually install Tendermint and be ready to start using it. Once you have this, we can do a very simple test. We have to initialize Tendermint first, so it's a proof of stake system, and you need some private key set up in the beginning to actually sign blocks and secure the blockchain. But once you have that, you can just say Tendermint node, and this then starts node, and give it a flag to test it, so we can run it with the dummy app. And right now, here we see blocks being produced and being validated by the underlying consensus engine. Of course, the dummy app doesn't actually do anything, so this is just a test to see if it works. But now we'll go into something more interesting. Let me pull up Emacs. Right. So what we'll also talk about later is how the Tendermint consensus engine abstracts away the business logic. When you think about how Bitcoin was developed, it's a very monolithic application. Everything is in one, so you have the peer-to-peer consensus layer, the peer-to-peer layer on how to connect to other Bitcoin nodes, you have the consensus layer of how the proof of work is implemented, and on top of all of this, you have the application logic, the UTXO model. What Tendermint does, it takes the peer-to-peer layer and the consensus layer and puts that into its own code base. And the application logic is completely separate. It's actually the way those two interface is over a socket connection. So it opens up a socket connection and then transmits transactions from Tendermint consensus to the application. And again, I'll go into more details later. So now let's program the actual application, the example application. And I'm going to cheat here and just insert a snippet because I didn't want to do that kind of risky live coding. And I'm just going to quickly walk you through what this actually is. This is a basic struct which just holds some state. And this is ephemeral state, so once we restart the application, it goes away. If you program like Ethereum like this, you'd want to use some sort of underlying database to persist the state. And then these messages are essentially what the application logic needs to implement. So it needs to know how to respond to, once it receives an info message, it needs to know how to respond to the response info. And again, snippets don't work great. I actually have to escape some backlashes. There we go, okay. So now let's go into the main file, and the main file is literally just how we hook up things and go. So we give it a couple of flags in the beginning, we create our application, we create our server. And by the way, if you want to build an application in Go, this is all given to you. Like, you can import all these backing libraries like the logger library or the server library and just give it an application, and you're up and running like 5 minutes with your own application. Okay, there we go. Save this. So now let's actually install this. And if you know Go, you might realize I've cheated slightly. I've downloaded the dependency beforehand because this would have otherwise taken 15 minutes. Okay, now we have the counter app. And this is our first application that runs on top of the Tendermint consensus engine. Now we want to start the Tendermint consensus engine. And for this, This time we just leave out the -- proxy app flag and rather just start it as such. Now Tendermint is waiting to connect to the application. And now we can start the application, and I will explain in a second what the application actually does. Ooh, live coding. Oh yeah. So Tendermint internally keeps some state. So I need to reset the Tendermint instance. Okay. Now we have to initialize Tendermint again. Kill this. Run Tendermint node. And hope that this works. Yes. So now our application. And as you can see, it's like super easy. It's like 50 lines of code you have to write yourself to actually get started. If you have an idea, it's like 5 minutes, and your first application that you can deploy to hundreds of nodes around the world. And now I will show you what actually happens. Now someone can submit a transaction towards Tendermint. And Tendermint will run this transaction through the consensus engine and gossip it to its peers, and then update the application state, so the business logic. And now is maybe a good time to actually talk about what Tendermint, what the application actually does. So all the application does, it keeps a counter. So you can submit a 1, or you have to submit a 0 first, and then you submit a 1, and then you have to submit a 3, a 2, and then a 3. But if you submit like a 10, then the application doesn't work. So it's a very simple application. It literally enforces that transactions or numbers are submitted in order. And the cool thing here is that we could be hundreds of users that are submitting transactions at the same time, and only one will ever succeed, and it's completely deterministic which one will succeed. So, well, actually, yeah, but so you have this global consensus, this global ordering of transactions. So now we try to submit a 5, but a 5 doesn't work, right? Because we've only submitted a 0 and a 1. Or a 0 actually. So now let's try to submit a 1. And this now succeeds again. So we've updated the state again. And yeah, this was pretty much already the demo. The last call is just a simple example of what kind of information Tendermint actually gives back to you. So you get how many blocks we've produced, and we roughly produce 1 block a second. So this has taken roughly 2 minutes to show. And with this demo, like this is a kind of stupid example, right? But it just shows you how easy it is to get started if you actually want to get started with Tendermint. And with this, I can switch back to the presentation. No, thank you. Yes, thank you very much, Adrian. Okay, cool. If you have questions about the application, which I guess some of you might have, please post them to Slido. I'll give you like a minute to do this, and then we'll continue afterwards. I'll actually have a look at the questions.
They said in the offer also through the WeChat in Chinese, so I will ask Haifeng to come.
Okay. No, I think I'll adjust a lot more time at the end. Yes. So now the next part is about why Cosmos? What problems are we actually trying to solve? And the two problems that Cosmos is tackling is scalability and interoperability. Scalability in the sense, scalability currently involves writing better applications, right? We want to write faster EVM implementations so we can support more than 10 transactions a second. But this is really not where the scalability comes from. We need horizontal scalability instead of vertical scalability. With the Cosmos Hub, we can easily support hundreds of thousands of transactions because we're not limited to writing faster and faster applications, but when we need more throughput, we can just spin up other zones. And Ash talked a little bit about zones, and I'll go more into depth about it. But you're not limited by the throughput of your application, because if you need more throughput, you can just add another instance of your application. It's very much like when Netflix or when Didi needs more capacity to handle more users a second. They don't rewrite the application stack. They add another server instance to handle the extra load. And I think one of the best analogies that I can come up with what this is on protocol level is, in the beginning we had, this is more like TCP/IP. Cosmos is the TCP/IP layer that enables the connection of different blockchains. So even though they're different blockchains with different application states, you can still connect them through the Cosmos Hub. Yes, so to the theory. So how does this actually work? And I'm not going to go into too much detail since Ash already mentioned it. We can have easy value transfer between zones. So we have here the Cosmos Hub, and then we can have theoretically more than one Cosmos Hub, and on a practical level that will happen, because we might have one geographical hub for Europe, let's say, one for North America, one for Asia. But for simplicity, let's start with one hub. So one Cosmos Hub can have multiple zones connected to it. And I'm going to use the example of Ethermint, which is our implementation of the EVM. And our implementation of the EVM, currently as a standalone zone, can handle roughly 200 transactions a second, which is already 20 times more than what Ethereum on the mainnet can actually handle. But this wouldn't solve our scalability problem, right? Because eventually, once everyone in the world uses it, even 200 transactions a second isn't enough anymore. What the Cosmos Hub allows you to do, though, is, let's say we have one Ethermint zone up here, and suddenly we're hitting the network limit, we're hitting the 200 transactions a second. We can easily just add a second Ethermint zone. And they have separate state updates, so they can run fully independently. But when you want to move money, or when you want to move Ether or tokens, or ERC20 tokens, between those two zones, you literally just go through a Cosmos Hub. And it's as if you have 400 transactions per second with one Ethermint instance. And theoretically, these zones can even just connect to each other. But on a practical level, once we have, let's say, like 10 or 100 zones, it becomes very inefficient to maintain direct connections between all the zones. So that's why, most likely even, from an economics perspective, there will be a hub forming, a hub that takes transaction fees for actually maintaining connections to all the separate zones. And as such, hubs are secure connectors for different zones. And I've mentioned Ethermint, but one of the zones could also be Bitcoin, a Bitcoin zone, or an Ethereum peg zone. And the way that this would work is that you have an Ethereum peg zone, which if you want to transfer money, and I will talk a little bit more about this later, how we can securely move money from the main Ethereum network to the Ethereum peg zone. From the Ethereum peg zone, you can now move it into the hub, and from the hub, you can move it over to the Ethermint zone, where you can now run transactions. By the way, if you have questions, please write them down. Because, yeah. So, now let's talk about the building blocks. So, what are we actually developing as part of this project? At the core of it all is the Tendermint consensus engine, which is a proof-of-stake consensus engine that I will explain in a little bit more detail later on. But you can just think about it that this Tendermint consensus engine has the ability to connect to other Tendermint consensus engines, so it does the peer-to-peer networking, and it does the global ordering of transactions. The next thing is the Cosmos Hub, and the Cosmos Hub is a multi-asset ledger, right? The only thing that it does is it tracks how many tokens a user or a zone holds within the Cosmos ecosystem. And it does, so it's actually a very simple kind of application, but it's at the core, so it's very important. And this is built on top of the Weave SDK. And by the way, we've done a bit of renaming lately, so all our documentation might not be up to date yet. But the Weave SDK, it's a cryptocurrency framework written in Go that allows anyone to easily build applications on top of Tendermint. This is also what is used by the Counter app, so that I don't have to re-implement everything from scratch, but I can rather reuse a lot of the components. Moreover, we're building the Ethereum peg zone because we want to be able to allow people to immediately move some value to the Cosmos ecosystem. And yeah, lastly, as I said before, we're building Ethermint, which is our first zone that's connected to the Ethermint and the Ethereum peg zone are the first two zones connected to the Cosmos hub. It's just that people have the ability to, for example, to deploy smart contracts. And interesting enough, I've been working with two projects, one in AI and one in token creation, that hit the limits of Ethereum and that didn't want unpredictability. That suddenly, if there's an ICO happening, the Ethereum network clocks up for 2 days, and you can't actually run any transactions anymore. And that's why I'm working with them on getting them up and running on Ethermint, because from a developer perspective, it is exactly the same ecosystem. So Ethermint is fully compatible with things like Web3. We run the same Solidity code, it's the same EVM. All the normal tooling that has already been built around the entire Ethereum ecosystem just works, but at 20 times the speed. Yes, now I want to talk about Cosmos apps, and Ethermint and the Ethereum peg zone are examples of Cosmos apps. Cosmos apps are things that connect to the Cosmos hub. And everyone in the world can build their own zone with their own business logic and connect it to the Cosmos hub. And that's really important to stress. There are no limits to what you can build. You can write it in your own language, you can write it in Haskell, Java, OCaml, it doesn't matter. You can write it in any sort of programming language you imagine. And the only requirement is that you implement one tiny protocol to be able to communicate with the Tendermint core instance. Do you have any other point about this? Oh yeah, and probably the coolest feature about all of this is that in most of the other blockchain implementations that try to tackle the scalability and interoperability issue, the problem is always that, let's say you're a private company like Didi or Deutsche Bank, and you want to run an application that connects to other blockchains or to the Cosmos Hub. You always have to open source your business logic. This is not the case with the Cosmos Hub. You can, if you're a private company and you don't want to open source all your stuff, you can run a completely private Cosmos app and connect it to the hub. So as a company, from a company perspective, you're still able to fully control the data, the users, the application of it. You're never giving away trade secrets, for example. But you're still able to securely interact with the rest of the ecosystem. You're still able to securely send tokens from your zone to the Cosmos hub, to a decentralized exchange where people can then change into a different token and back. As an example, I'm going to give you Airbnb. For example, if Airbnb didn't want to pay credit card fees anymore, they could choose to pay their hosts in Airbnb tokens. And they could choose to implement this as a Cosmos app. With this, every time, let's say I stay at an Airbnb, my host doesn't get paid in US dollars. He gets paid in Airbnb tokens, and they're issued by the Airbnb zone. My host might not have much use, because he might not use Airbnb actually, so he can't. So he wants to use his Airbnb tokens for something else, right? But so what does he do with his Airbnb tokens? Well, he can move them to the Cosmos hub and then to his exchange or decentralized exchange, or pay on some other zone of them. Suddenly, private companies can issue tokens that are fully compatible with the rest of the ecosystem. I know this was a very quick introduction, but I hope that I've given you some sort of idea of what the Cosmos Hub can do and what Cosmos can do and how you can use it. We will dive more into the technicalities of it later on. But one of the things that I really want you to take away from this is that we can't be building blockchain applications in silos anymore. We really need to get into this, first of all, interoperability mindset plus scalability mindset. If we really want to take blockchains to, let's say, even just China, we need to have a way different approach that needs to be closer to what we did with the internet than what we're currently doing where everyone is building silos. Yeah, so thank you very much. Again, and yeah, maybe now let's actually take some questions.
We have one microphone. Actually, Haiphong or where is Haiphong?
I already submitted questions to the address.
Okay. Can you help? Can you come up to help?
Oh yeah. Yeah, true.
So what we should do is, actually, there are some Chinese questions. So I will ask Haiphong to ask that to English to Adrian.
There you go.
I think I already posted the question to the address.
Yeah, this is it.
All right. So,
Now, so if you have a question, I can clarify.
let's see.
Oh, you already translated that in English.
That's right.
Oh, very good.
Okay, now let's see if the internet works.
Right. So let me slow.
Yeah. Give it time, right?
It does. All list elements on the page that are referring to some resources you can get to.
I tested this morning, it should work. Oh. Alright, let's get to it from a phone. Okay, well, in the meantime, we can actually, if you have questions on WeChat, let's just take them.
Yeah.
You can read it out.
Or if you actually see the other questions, that'd be great too.
Yeah, so you can copy those questions from WeChat group. 第一个我先用中文啊，然后再翻译成英文。第一个问题就是说，之前比特币最多只能有3个托管人，就是从多签来说啊。然后现在比特币隔离见证以后呢，据说对这个多签支持比较好。那么现在呢，不知道能否支持大于3个人的多签名，进而能支持100多人的 Cosmos 验证人集合来托管 BTC。这一块呢，实际上我对这个问题理解的也不是特别好啊，不知道这个翻译对不对啊？ So Adrian, here's the question. So, Bitcoin multi-sig used to support up to 3 signatures. With activation of SegWit, can Bitcoin now support multi-sig with more than 3 signers? So this is the first question. The second, and how can Cosmos 100 validators be trusted to secure BTC? Or and later, then the following sentence I added. So, or maybe this SegWit is an irrelevant issue with Cosmos validators.
So yes, I don't know enough about Bitcoin to say whether Bitcoin with SegWit supports more than 3 multi-sig signatures. For Cosmos, it is not a relevant issue itself. It might be for the Bitcoin peg zone because we ideally need at least 100-person multi-sig wallet or multi-sig to be able to have 100% security behind the Bitcoin peg or in an easy to manage fashion. But in itself, the Bitcoin issues are not a problem for Cosmos.
准备回答你的问题了吗？没太清楚是吧？他的问题是我理解是这样，他说实际上这个Bitcoin multi-sig 的这个问题和这个Cosmos 100个见证人这个是不相关的一个事情。他说 Cosmos 这个 validator 和这个不相关，我理解应该是不相关的。具体细节我觉得我们要下来这个是专门跟那个 Adrian 讨论一下。OK, the second question， 就是比特币和以太坊转接桥的具体架构是怎么样的？大概何时上线？What are the architectural details of a Bitcoin or Ethereum relay bridge or peg zone? I think. When will they be up and running?
So the Ethereum peg zone will be up and running by the end of this year. From an architecture point, it is that on the Ethereum side, there is a Cosmos bridge contract, which is controlled by the Cosmos validator set. So it's literally a multi-account holder. And when you want to move Ether from Ethereum into the Cosmos ecosystem, what happens is you send, let's say, 1 Ether into the Cosmos bridge contract, and then the Ethereum peg zone needs let's say their validators running the Ethereum peg zone, right? Everything needs to be backed by a validator. These validators are also running full Ethereum clients, so they see the state updates that a transaction, that some money has been deposited into the Ethereum smart contract, the bridge contract. when, let's say, after 12 confirmations, so because with proof of work we always have this problem that we actually never have finality. Once we have the money locked up there with some sort of security, they can create a peg ether on the Ethereum on the Ethereum peg zone, and then that peg ether can be moved into the Cosmos Hub and to the wider ecosystem. On the way back, you move it back into the Ethereum peg zone, and then the validators have to submit a proof that this transaction actually happened within the Cosmos Hub, and send that towards the smart contract and the bridge contract. And the bridge contract itself is tracking the validator set changes of the Cosmos Hub. So if they receive a valid transaction, a valid proof, they release the money back to whichever account you wanted.
Okay.
This is from a very high level, by the way. There's a bunch more incentives in terms of how you can report fraud and things like that.
OK， 这个我大概听懂了对吧？对，你需要我大概翻译一下吗？需不需要？实际上这个有好多细节，但是大体上是这样的，就是说，一个就像以太坊这样已经存在的区块链，它本身不是基于Tendermint 的，所以在它和这个 Cosmos Hub 之间，你要建一个 peg zone， 这个 peg zone 是基于 Tendermint 的。那么这个 peg zone 里面 run 的这些 validator， 它必须是以太坊的 client。那在以太坊里面呢，会写一个叫桥接的 smart contract 智能合约。那就是说，如果是有谁想从以太坊向Cosmos 转账的话，他就实际上是要在以太坊里向这个桥接的这个 smart contract 转账。然后这个转账经过这个Merkle proof 一段时间确认以后呢，会被这个peg zone 里面的这些 client 会观察到，然后他们就会把这个就相当于在 peg zone 里创建对应的叫 peg ether， 然后这个 peg ether 呢再通过 IBC 协议传送到那个 Cosmos Hub 里面，然后 Cosmos Hub 最后产生相应的这个就是说对应的一个基于 Merkle proof 产生一个相应的这个转账的一个记录。那反过来就是这个过程也是类似的，那就是通过Cosmos Hub 里面的 validator 要提供一个交易的 Merkle proof 到 peg zone，peg zone 验证了这个交易以后呢，会创建相应的 peg ether， 然后把这个 peg ether 写回到那个smart contract 的另外的方法里面，然后 smart contract 验证以后呢，会释放相应的这个锁定的这个 ether。大致这和侧链是非常像的这样一个过程，大概是这样。但是这里有很多细节啊，他也说了，这里没办法讲很多细节，大概是 OK。他什么？对 ，What about Bitcoin?
You mean for the Bitcoin peg zone?
Peg zone, yeah.
In terms of when it's up and running?
Yeah, when will it be up and running?
Sometime next year. If you're very much interested in building a Bitcoin peg zone, please talk to me and talk to the team. We're definitely looking for people to help us with the Bitcoin peg zone, because from a technological perspective, it's actually the Bitcoin system isn't great to build peg zones. Yeah. Smart contract linearities are great. Right, there was another good question. So the question is, how do you make smart contracts terminate on Tendermint? Tendermint itself does not implement the smart contracting language. So with Ethermint, we are we're leveraging the EVM and the EVM's termination model to put that on top of Tendermint consensus. So the termination issue has to be handled from the application logic. Tendermint itself is completely agnostic towards what kind of application you're running. The only requirement is that your application needs to be fully deterministic, because on seeing the same transaction, every single instance of that application needs to come to the same conclusion. Can you elaborate on the Weave SDK? Yes, the Weave SDK is it's a cryptocurrency building framework written in Go. It easily plugs into the Tendermint consensus engine. And it's written in a style similar to how you write web servers. So there you have middleware, and with the Weave SDK, you have to define a bunch of middleware that processes your transaction and then eventually updates your state. But we provide a lot of commonly needed middleware like signature checking, authentication checking, transaction fee deduction, and so on. And we're constantly developing it since we're building the Cosmos Hub on top of it.
这个 Weave SDK 这个，我简单说两下，这个他没有提，它是这个 Weave SDK 实际上它就是现在你要到这个 GitHub 上看，它实际上就是 Basecoin project， 它以后就不叫 Basecoin 了，它就把它改名叫 Weave SDK， 它实际上就是基于 Tendermint 构建的，然后它相当于以类似像中间件的这种架构搭建的，像 Web Server 或者 Web Service 这样，它提供了一系列的中间件服务，像这种authentication 就是验证啊，还有就是签名的验证啊 ，Merkle Tree Proof 啊这些，所以使得让你就是构建一个跟这个 Cosmos Hub 集成的这样一个zone 呢就变得非常容易，而实际上在这个 Weave SDK 这个新的术语下面，它这个 zone 呢也同时也就等同于叫Cosmos Application， 就是你在听到说 Cosmos Application 的时候，实际上就是等同于 zone。
Maybe let's pick like 2 more and then I'll continue with more technical part as well. Oh yeah, so actually we've covered this one, like the app is running independent of peer-to-peer and consensus. How are we ensuring business level consensus via peers? Via full determinism on the app side. If the first instance of an app receives one transaction, the second instance receives the same transaction, they need to come to exactly the same state changes, no matter, they just need to come to the exact same state changes. So it needs to be fully deterministic. You can't really use random numbers, you can't use floating point operations. All the sources that, for example, in video game programming you have of non-determinism, you can't use, also apply to building Cosmos apps.
对，他说，为了确保 business level 的这个一致性共识，在就是这个 ABCI application， 所以现在好像术语也改了，叫 Tendermint application， 必须是完全确定性的，也就是说在你写代码的时候，不能用任何非确定性的这个语言特性，比方说随机数啊，还有这个浮点数啊，这些都是不能使用的。所以这样就确保在每一个节点上执行的业务逻辑结果都是完全确定的。
Okay, and let's pick this as the last question for now. What is the concrete progress with the hubs, reward, and penalty mechanism? Are they done with Ethermint, smart contracts, or through an underlying protocol? Ethermint is an application written on top of Tendermint, and as such, so Ethermint has nothing to do with the reward and penalty system. That's all handled by the Cosmos Hub, and the Cosmos Hub is right in the end also an application written on top of Tendermint consensus. The Cosmos Hub is if someone in the network can prove that, for example, a validator double signed for a block at the same height, they get slashed, so they lose their deposit. But I will talk more about the staking and the security of staking during the technical part as well. But yeah, this is all handled within the Cosmos Hub, not within Ethermint.
OK，所以问题就是说，这个 Ethermint 是一个基于这个Tendermint 协议搭建的一个 EVM 兼容的一个应用，它和这个Cosmos Hub 没有任何关系，因为 Cosmos Hub 也是只不过是你要从这个角度来说，它是基于 Tendermint 的另外一个应用，所以在等会儿在这个这之后呢，这个 Adrian 会详细的讲，就是Cosmos Hub 里面是如何对就是这个 validator 的一些不好的行为进行惩罚的这个机制，他会讲的。但是这个机制本身呢是通过 Cosmos Hub 的这个协议实现来完成的，跟 Ethermint 没有关系啊。
Alright, cool. Let's jump into the technical part. This again is not a super deep dive, but it highlights how it works more from a developer perspective and what you have to do to build your own apps. Let's start with basics. So at the core of all of this is the Tendermint consensus engine, which I've mentioned before is a proof-of-stake consensus algorithm that guarantees safety and liveness, and at the same time is optimally Byzantine fault tolerant and fork accountable, which is probably one of the more interesting things, because with most proof of stake implementations, you can't actually, if there's a fork happening, you can't actually tell who caused this fork. So it's very hard to slash people once the fork has happened. With Tendermint, you are fully aware of who caused the fork, and hence we can slash them accordingly. This is at the basic of the staking implementation, that if someone misbehaves, we can see who misbehaved, and we can punish them accordingly. Oh, and well, this is also kind of important for software engineering. Tendermint itself is super simple. It is like 25,000 lines of Go, and that includes the peer-to-peer part and the consensus part. If you're really interested and want to see if this actually works, like we say it works, it takes you like 2 weeks to read the code base and figure out whether we did anything wrong. When you look at a lot of the other proof-of-stake implementations, they are much more complicated, usually not well specified, and usually mixed together with a lot of the application layer. So it makes it much harder from a developer perspective to actually verify that they do what they say they do. And this, of course, is also important if you're a company that wants to build like some enterprise application that hooks into the Cosmos Hub. Because you can literally hire 2 engineers and figure out whether the thing you're building on is safe. And I've mentioned Byzantine fault tolerance. And the only really important thing here to remember is that with Byzantine fault tolerance, you can have malicious actors in the system. So you can have people that are actively trying to disrupt your consensus, and as long as it's not more than 1/3, it causes absolutely no problems. Yeah, so why is Tendermint built as proof of stake? Or how is Tendermint actually built with proof of stake? Tendermint uses security deposits instead of wasting electricity. When you look at where the security in Bitcoin comes from, it's from the fact that you can't actively mine on 2 forks. You have to make an economic decision on where to invest your mining power, and you have to pick 1 fork to mine on, right? You can't mine on 2 forks at the same time without halving your hashing power. With proof of stake, the problem is actually that it is extremely cheap to produce blocks, which also makes it extremely efficient. So we don't have to waste massive amounts of electricity to secure the network. But this comes with the problem that right now I could support like 10,000 different forks on my laptop because it's literally like 1 signature. The way we combat this in proof of stake is by saying you have to put a security deposit down. And if you sign 2 blocks at the same height, you lose that security deposit. So at that stage, there's now an economic choice to be made for you. It is not economically feasible for you anymore to run the consensus on multiple forks at the same time, but rather the same as in proof of work, you now have to pick which fork you want to work on, or which chain you want to work on. Moreover, Tendermint consensus is, as far as we can know, it is secure, and we're currently getting that formally verified by the same kind of guys that do a lot of the distributed database testing. So think about like MongoDB testing. They're running test suites against us right now. They've discovered, I think, a tiny liveness bug, which we fixed by now, but they haven't managed to violate safety yet, which is kind of good for us. And again, there's a full specification on GitHub of how this algorithm actually works, how a proof of stake implementation works. If you're really interested, you can just look at the specification and build it yourself. A lot of the other proof of stake algorithms that are out there are documented in random blog posts, and no one can really tell how they work, which is why it's very hard to actually fully understand if they're secure. And as far as I know, Tendermint is one of the only ones. It's the only one where it's very clear how the algorithm actually works, and it's very well documented how the algorithm works. Yes, so security through staking. as I mentioned before, in Bitcoin you have mining powers, you have to have an economic choice on which fork you're going on. In Tendermint we're using staking. As such, there is a token called the atom. And this atom is used very much like mining equipment. One atom, you can think about an atom like a 1 GPU unit, where you use this 1 GPU to secure the network. And as such, atoms aren't meant as a medium of exchange. They're not like ether. They're not a medium of exchange or a store of value. They're really mining equipment. And you have to have this mining equipment to secure the chain and nothing else. And then there's this concept of validators. So within the Cosmos Hub, there will be 100 validators. And these validators are tasked with securing the chain. In an ideal world, you would have as many validators as would want to participate in the consensus. However, this introduces a massive amount of network overhead, since you suddenly need to connect to all the different validators and involve them in the consensus process, which is also which is related to another feature of Tendermint, which I'll talk about in a second. So we have 100 validators for the Cosmos Hub that have to put up a security deposit and then contribute to the consensus and security of the network. And you could say this is more centralized than most other things. It's not as egalitarian as, for example, proof of work with Bitcoin or Ethereum. In reality, this is probably actually more decentralized, because with Bitcoin, I think the 4 biggest mining pools control like 50% of the network. So even if you only have 100, this is still far more decentralized than actually Bitcoin. And the important thing is, you don't need to be one of the hundreds. You don't need to be one of the 100 biggest atom holders to participate to become a validator. Because other people, let's say you want to run a validator, the rest of us can delegate our atoms to you, so we can delegate our mining equipment towards you. So you can still become a validator even though you only might have 1 atom. So validators are very much like big mining pools that don't waste electricity. Yes. With Tendermint, we also have 2 more really cool properties. One of them is that we can have very efficient light clients. When you want to build a light client on top of, let's say, proof of work chains like Bitcoin, the problem is you have to keep up with constantly with the headers. So your light client needs to be constantly connected to the network, needs to be constantly processing headers, which, if you, for example, want to run it on a phone, is a real problem because it wastes battery and it wastes your data plan. With Tendermint, since we have this concept of the validators, as long as the light client keeps track of the changes in the validator set, so the people that are validators, which should happen roughly once every 30 days, the light client only has to connect once every 30 days. And if they receive a block within that time, they can just look at the block and be fully certain that it's a valid block, because they can check whether it was signed by more than 2/3 of the validator set that they know about. And if that's the case, it's a fully secure block that was included in the chain. Oh, right, and the other cool thing is we have immediate finality. So within 1 block, you know whether your transaction was included. With Bitcoin, the problem is that, or with Ethereum as well, that from an application perspective, it's very hard to build on top, because you always have to take into account that you might not be on the longest chain after all. So you always have to deal with the fact that maybe after 6 transactions, you have a rollback where you didn't end up on the longest chain. With Tendermint, since we agree on the transactions before we produce the block, we know that these transactions will be in the final block. So after about 1 second, once the next block is mined, or once the next block is validated, you are certain that your transaction has been included. It is very much more like a normal response and request model, where if the network tells me that this has gone through, it has gone through. So from an application perspective, it's much easier to build on top. Okay, so this is now actually the magical part where I'll tell you how this abstraction works, that the application logic can be completely removed from the consensus and peer-to-peer layer. And I will walk you through a basic example. I will walk you through what actually happened when I ran the counter demo. When I ran the counter demo, what happened was that I submitted a transaction on the client side. So I submitted a 0. And then this yellow thing is Tendermint, the Tendermint consensus engine, by the way. And this green thing is the application logic. So what happened when we submitted the 0 was that it goes into something called the mempool. And this is where we store incoming transactions. Once Tendermint receives a transaction into the mempool, it makes a message call towards the application logic that is checktx. And in checktx, Tendermint sends the application the transaction it received, because Tendermint is fully agnostic to the transaction. To Tendermint, it's literally just bytes. Tendermint does not care what your transaction is. So it calls checktx, and now the application logic has to go and say, is this a valid transaction? And in the case of the counter, it was, have I seen the 0 before? If yes, then this is not a valid transaction. Or is it not in order? So is it out of order? So is it 0, 1, 2, 4, for example? And in those two cases, it just rejects. It lets Tendermint know, no, this is not a valid transaction. And then Tendermint just throws away the transaction, right? It's not a valid transaction. The interesting part here is that, for example, in the case of Ethermint, this application, this checktx logic is actually much more complicated. In Ethermint, what happens is the Ethermint application logic looks at the transaction and says, is it internally consistent? Does it have all the right fields? Does it decode correctly? Is it signed properly? Is the nonce correct for the account? Does it come from an existing account? Or does it come from an account that has money in it? Does the account that sent the transaction pay for transaction fees? Does the account have enough money for the value transferred in the transaction? So this checktx is very much up to the application logic, and you can decide to do whatever verification or whatever checks you want to do on transaction, Tendermint gives you. Then the next step, the next major step, and by the way, so there are more than 2 message types. There isn't only checktx and delivertx. No, we call it, this is an old graphic, it's called delivertx nowadays. There are, I think, roughly 10 or so message types, but they're all very similar, very well documented on how to implement them. And if you're writing in Go, it's already almost all the decoding is handled for you for these messages. So once we decide then to create a new block, the Tendermint core instance says, right, I'll take these 1,000 transactions or 100 transactions. It agrees with all the nodes in the network that these are the 100 transactions that should be included in the next block. And once they have reached agreement, each of the nodes in the network, each of the Tendermint instances, runs them against the application logic. And this is where actually the state change is happening. So now we have a transaction, the Tendermint core gives it to the application, and the application now has to update its state. So it has to update the database that's underlying the application. It does that 100 times, and the call finishes with a message called end block. On end block, the application's only job is to return one state root, one hash that represents the entire underlying database, so that this state root can be included in the next block in Tendermint. And here the determinism comes in, because if your application is not fully deterministic, they reach different state here. And that means that the state root that you return is now different, and Tendermint will fail on this. Because this means that Tendermint can't actually accurately keep track of the state that your application should be in, which makes everything else not work. So determinism is very important. Oh, and yeah, this is called the Tendermint socket protocol, and this is the only part that your application has to implement. Yes, do you have questions about this right now? Because I think the next part is about scalability and interoperability. Anyone? Questions? Like, do we have a second?
I want to ask the chip parent for, one the validator to check if there a process for computing the hash just for an easier target? Or transparent for I can forecast who will generate the next block?
Oh, right. No, you can't determine who will generate the next block.
So there is also a computing hash process.
Well, you can't, let's say it like this, you can't predict who the next proposal will be far into the future. On like a block level that might work, but it won't work for more than like 2 blocks. So you can't predict far into the future.
Thank you. Another question. Is it possible to transfer the message in the call?
To change the message types?
Yes, a secure message.
What do you mean by secure message?
I mean, I can just transfer the coin, or I can also insert a secure message in the transaction.
I don't understand what you mean.
除了简单的进行币的交易，我们可不可以在币的交易中加入附加的信息，比如说安全的一些消息，加入或者彩色币之类的功能？
This question is really, in addition to coin transfer functionality, can you include extra semantics in the message, in the different types of messages?
So in the transaction, yes, right? So this transaction over here can be whatever. It doesn't matter. Like Tendermint does not care. As long as the application can handle that message, it can be any sort of arbitrary message type.
Okay. 所以这个 transaction 可以是 application specific， 因为它对于 Tendermint core 来说它是透明的。你只要你的 application logic 可以 interpret， 可以理解你的 transaction， 可以处理它就可以了。
Yeah.
So the application, let's say you have the application running 2 copies of it. And you have an asset, like a piece of real estate, and 2 people at the exact same time, or near enough, within the same block. One of them decides to transfer it to this guy, and the other decides to transfer it to this guy. What's going to happen?
Yeah.
They're running on different apps. So how are you going to come to some sort of consensus to this? Obviously, your root hash thing is not going to match, etc.
So they will be running on the same application, right? They will be running on a separate instance of the application.
Yeah.
It's
2
this,
instances.
yeah.
In one instance, it gets the message to do, A, and the other give it to B.
Yeah. That would not happen because the transactions will have been determined before we actually run the state changes. So, where's the clicker? So, Tendermint core here determines the 100 transactions to run. So, no 2 applications will receive different ordering of messages unless they're malicious or unless they have been targeted by a malicious actor. And if this
So just to modify the question slightly. So let's say that your logic basically said, if the account value is greater than 100, then transfer to A and deduct 10. And if it's it's less than it, transfer to B. And so, there's this ordering logic then, and so we're at the value 105, and so from one perspective, we're supposed to do one thing, because it's greater than 100, and so now we have this kind of fork in the logic that bifurcates both based on the initial state, that we have a different set of final states that we're supposed to reach. And so within one block, we could have, depending on how you order the things, so how are you coming with the ordering? Like, if 2 people submit things independently, are you just doing it based on the clock or what?
No, so the ordering is determined by the consensus engine, right? So the consensus engine, Tendermint core, the consensus engine, decides on the ordering of transactions. And all applications run the same transactions in the same order. They're not, so this step is the same in all applications. Right? So if there will not be a fork if the application itself is deterministic, because they would increase the account balance by 1, all of them would run that, and then deduct it by, let's say, 5, all of them would run that. So there's not the case that one application would see the -5 transaction first and then the +1. Any other questions?
This is a simple one. So what's the role of Atom, the Cosmos coin in this system?
Yeah, so the Cosmos coin is there to provide an economic incentive so that validators don't cheat. Because in Bitcoin you have the economic incentive being wasting electricity on the wrong thing. Here you need atoms to participate in the consensus, and if you cheat you lose your atoms. That's what atoms are really for. You can think of them like mining equipment for proof of stake.
So in other words, it's not like the gas. It's not the same mechanism of Israel.
No, it's not gas. We're currently speccing this out in terms of economics and we're releasing this in like a specific white paper for that as well. There will most likely be a different coin to pay for transaction fees. Right.
So which means there will be a mechanism.
Oh yeah, there's a mechanism to prevent spam.
Otherwise,
Yeah.
sometimes people are just doing this work.
No, yeah, there is a spam prevention mechanism, don't worry. We're not that well known.
I just want to add one more thing. What's the cost of this? Well, we don't have the cost.
I don't have copies though.
Okay.
All right, so one thing about Atom, right, just want to add that. If you look at our Cosmos logo, that O there has a 0 and then slash, right? That's actually hold the meaning. And that's why we call our global hackathon Hack Atom, right? Because it is, you hack the atom. So if you do something bad, your token, which is your atom, will get slash. That's part of the punishment. So I just want to make sure this is kind of clear. There's meaning on this logo. So anyway, go ahead.
Yeah, I'll check.
I have a question about but will there be any rewards for people who run validators? So
Yes, validators do earn transaction fees first of all, and they might earn yearly rewards for actually participating in the consensus. So you can see most likely 5% increase in your atom holdings every year. So you are rewarded to become a validator. But again, we're currently speccing out the exact economics. So if you're interested in becoming a validator, you have to wait like 2 months before we release the entire economics behind this.
the final question. So those slashed atoms, where did they go?
They're burned. They just disappear. To keep it simple. Did we have other questions online? Well, so I think the last question, for blockchains not involving tokens at all, can I make a transaction or use the Cosmos network? Yes. Because tokens, in the end, are the only thing that tokens are really useful is spam prevention. And in case of Ethereum, also determinism. And if your application can handle terminating in some way and prevent spam in some way, so for example, you could use the native fee token in your application as well, then you don't have to have tokens inside your application, as long as you can guarantee that it terminates eventually. I'm guessing that was your question, by the way. Oh, really? Okay. Good question, though. What's the process of validator selection? We're currently arguing about this as a team. It will be that we will have a phase in which you can't send tokens, and you can only stake atoms to other validators. until we have a minimum threshold of validators. Let's say like we at least have 50 validators, at which point you will then be able to use the network. You can think of it very much like Ethereum started, where initially they didn't allow transactions until they were certain the network was stable. This is kind of the same thing, so we will have a process where I, as a tiny atom holder, for example, I don't want to run my own validator because it's a lot of work, needs to be constantly online, it needs to be very secure. So I rather choose to delegate to you because you might be like a company like Red Hat that is very good at running network infrastructure. So you're running our validator, a bunch of us are delegating to you. This is happening around the world, so a bunch of people are delegating to different people, to different validators, and then the top 100 people with the most atoms delegated to them, so the biggest mining pools essentially, we should call them validation pools. The biggest validation pools now validate the network. And as soon as the 101st validator passes the 100th validator, we switch validators. So it's a very dynamic process where the validator set could update every once in a while because suddenly I don't trust you anymore, so I delegate to you, now you're in the top 100, and now you are validating. Yes, so how can you convince other people that you're actually trustworthy, they should delegate to you? You can cryptographically sign, for example, with a certificate that you got from a certificate authority so that people know your real identity. You can somehow establish that you're a real person or that you have knowledge in running a validator. But that's very much up to you there could be people that run validators completely anonymous if there's enough people trusting them. And the next thing might be that you just might have to put up a lot of atoms initially so that people believe that you have skin in the game, right? Because if I only have one atom and everything is delegated to me and I'm fully anonymous, I might not care whether I get slashed and lose half of all my atoms, right? Because I only lost like half an atom. So initially, they might have to put up more atoms. Let's go back to the presentation. I have like some things left. And after that we can run through all the remaining questions and any questions you might have. So scalability, how does it work actually that you can have multiple blockchains connecting through a central hub? That works through a protocol called the IBC, the Inter-Blockchain Communication Protocol. Should we get out of the way? And it's actually a very simple protocol. You have two message types, IBC block commit and IBC packet TX. IBC block commit TX and IBC packet TX. And it essentially allows you to update the latest block. So I'm running my own chain, so I'm now able to send the latest block header to the hub, and then that's the first message type, and the second message type is that I'm generating a proof that some sort of transaction has happened within my state, and I'm proving that to the Cosmos hub. And that's really all it is. And there was also a question about whether we'd be able to move something arbitrary state, so something besides tokens. That is kind of the holy grail, and we are actively researching into that topic. Currently it's not possible, at least not in a secure way, so currently we can only securely move tokens between different blockchains. But from a very simple perspective, it literally involves I send a coin to the hub, and then the hub sends the coin to the other, my zone sends a coin to the hub, and then from the hub I go to another zone. And it's a very simple protocol, and it's the only thing that people have to actually implement to be able to join the hub. You can also see this a little bit. So how the hubs work, right? So you have one central hub, we have multiple zones connected to it, they all connect over IBC to the hub, and they can all work like this. In a theoretical sense, they could also, let's say you have two zones that are very high traffic, so they do a lot of transactions between each other. Those two zones could choose to connect directly, but it is generally not advisable because the Cosmos Hub has actually the important functionality of maintaining this global invariance of how many of each atom, or how many of each token are currently in the Cosmos Hub. Oh yeah, and the cool thing in terms of security for this, or in terms of, not security, but rather fault tolerance, is we can have more than one hub, and hubs can be competitive. Any one zone can become a hub, as long as everyone else chooses to do the transactions through that zone. In that sense, we can have very highly fault-tolerant systems that actually can handle network partitions. Let's say that Shanghai, for example, could have its own geographical hub, and then all the zones within Shanghai connect to this hub. Even if the rest of the world goes offline, it doesn't actually matter to Shanghai, because all transactions within Shanghai can still be processed. We just can't send money or receive money from the rest of the world. Now think about how this currently works in Bitcoin. If one mining pool goes offline, it takes like 20% of the mining power with it, suddenly you have a huge problem, even in the rest of the world. So somewhere in South America, we could suddenly have problems that we can't process transactions as fast anymore. With the Cosmos Hub, we can have this hierarchical structure of hubs, of regional hubs, down to the lowest level, that make it possible that even if the rest of the system goes down, due to some network fault, for example, you can still do transactions locally. And if you're into like local coins and keeping money within the local economy, this is also a really cool research topic for you on how you can build local coins that can't like leave your hub and have to be spent in the local economy. Zones. Yes, I talked about zones. Oh yeah, one last thing about zones is actually, you might wonder, can any zone create any arbitrary token? And the answer is no. So for one token, let's say for the pegged Ethereum, pegged Ether, there's only one source zone. And only that zone can create new tokens. The other zones can still move the token around. That's not a problem, but they just can't create additional tokens that goes over the balance that they have on the hub. That enforces a global invariant that we have to have the same amount of tokens across all zones, so that zones can't cheat. That's really it. Oh yeah, scalability. This is a fun one. So currently, Tendermint itself supports roughly 30,000 transactions a second. That's without an application level. Ethermint supports roughly 200. And again, so even just the raw speed, even if we just have one zone, we're just way faster than any comparable system. Of course, when you take into account that we can arbitrarily scale this horizontally, we could be at like 120,000 transactions easily as soon as we have 4 Tendermint instances running. Yeah, so zones can contain arbitrary business logic. If you're really fancying it, you can write your application logic in like Java 4 and use the most archaic technology possible. As long as it's deterministic, it still will work with the Cosmos Hub. Of course, you have to get users to use your application, so you might not want to run it in Java 4. Yep, they synchronize through the peer or the hub. Yep. Oh yeah, and I mentioned this earlier on, but I really want to stress this. If you're a company or if you're a startup and you don't want to open source your application logic, that's fine. As long as your users are willing to use you, you can still run it on the Cosmos Hub as a Cosmos app. We don't care like how your application logic works, because ultimately you are responsible for your application logic. So if something goes wrong with your application, people will maybe start suing you, or you lose your reputation, you lose your business. But this entire thing, that your application logic is completely up to you, and we don't care. Yeah, so I'll just give you a quick run through of the apps we're developing. So it's Ethermint. Ethermint is the EVM implementation on top of Cosmos. It's fully compatible with all the existing Ethereum tooling, with all the existing wallets. It works with like the Ledger S, Web3, all the RPC calls are Web3, everything really, but at 20 times the speed. We have the Weave SDK. I talked about this earlier as well, cryptocurrency framework, we're building the hub with it. It's a very active project right now. Well, all of our projects are very active, but particularly this went through a lot of breaking changes in like the last 2 weeks since we were on a retreat. So the documentation currently is very much out of date since we fixed changed a lot of the code. So unless you really want to dive into the code, I might give it like a week to fix the documentation. And this basically allows you to build your own cryptocurrencies. If you wanted to build a cryptocurrency, let's say last year you had to worry about, you could use one of the big archaic C++ code bases, or you had to build everything from scratch. With Weave, it can be like maybe 300 lines, 400 lines, and you have your own cryptocurrency up and running. We are of course building the hub. Currently we're very much focusing on the security, so how do we do the slashing? What validators misbehave? How do we prove that validators misbehave? Oh, and when I'm saying we're currently building it, this is all fully specified, we're just implementing it. We're building the Ethereum pack zone, I talked about this earlier as well. Since this is one of the bigger projects that also involves like external things, this is quite not as straightforward as most people would think, but still very doable. So if you're now interested in like building your own things on top of the Cosmos Hub, you have like 3 choices. So you can build on top of Ethermint, which is probably the easiest way if you want to get a quick prototype out there, because you can just use Solidity, and there are a lot of good guides on how to use Solidity to build your own cryptocurrencies. Or you can use one of our language SDKs. So we currently have the Tendermint socket protocol implemented in all these languages, and I think we've also added Haskell lately. But even if it's not implemented in your favorite language, it's probably like 200 lines of code to do it. It's really not a complicated protocol. So this is really the way to get started. I would heavily suggest, if you're a developer, I would go for like option 2, because it's probably the most powerful, because you have the most flexibility. But if you just want to get something quick and dirty up and running, just use Solidity. And just one idea on what kind of application you can build is you can build awesome banking apps which are not susceptible to man-in-the-middle attacks at all. Because the banking app can be a light client towards your application logic. And the light client itself can verify all the data it receives. It doesn't even need to run over a secure connection. This our blockchain is secure by design on protocol level. We don't need certificate authorities to authenticate it. You have to trust one thing when you run this app. You have to trust the initial validator set. But as long as you trust the initial validator set, very much like you trust the initial Genesis block for Bitcoin or Ethereum, you're fully secure as long as you come online once in a while. Yeah, I think that's probably one of the most interesting apps you can build right now, because banks might pay you a shit ton of money to do that. Questions? Right, next steps. So, I followed Jim's advice and put in a pun. You are on the brink of discovery, and I really hope that you took something away from this talk, and that you now have an idea on what you can use the Cosmos Hub for, and how you can build Cosmos apps. If you have questions about this, I'm still available later on, so please ask me. And this will really be the future of cryptocurrencies, because this is one of the only projects that tackles interoperability and scalability at the same time. So, as to the future roadmap we're taking this project, we should have production-ready testnets up in October, so where all the slashing logic is implemented. And if you want to run your own validator on the testnet, like join our Rocket Chat instance, start talking to us. We're slowly adding validators from the community to actually test for those, to find any bugs. And depending on how well this goes, we will have a live network towards the end of the year, where there's actually real value involved and you can have real uptime expectations and everything. So, how to learn more? We're currently working on making it way easier for people to start getting involved with Tendermint and Cosmos. So, we host developer chats every 2 weeks. So if you have questions, immediate questions, That's a good place to start. They're also recorded on YouTube, so you can watch them later on. We also have a YouTube channel. I might be working with our local partners to also get this up on the Chinese version of YouTube, because that might be way easier for you guys to access. Yeah. Plus we have blogs. We also work on translating them into Chinese. And these blogs explain a lot of the things around how do you build your first app, how you connect to the testnets. Oh yeah, by the way, we currently do have like 3 testnets up and running, but they're very early stage testnets. So if you're looking for like proper, you might want to run it locally instead. We also have mailing lists, so do join our mailing lists. And we do regular meetups. So I think Bianjay is going to run more meetups as well. So that's really the places where you can learn more. If you want to get in touch, we do have WeChat groups, we have Rocket Chat, over email or GitHub works as well. If you're a developer and you find issues, please post them to GitHub or let us know on Rocket Chat. Yeah, so upcoming events, we will have some meetups in Korea, we're going to have some more meetups here. There's a conference happening in the US, so if you're in the US, that's a good place. Hack Atom is currently happening, right? So maybe today's even a good time to meet your team. And a lot of the team behind Cosmos will be at DEF CON 3 in Mexico. So if you're around there, come find us. I think we might be giving out like little gimmicks in the form of atoms. Yeah. So extra resource, by the way, I'll distribute these slides afterwards. So like, these are all links and you can find them. And oh yeah, and we're currently working also on educational series. So like how to build your first application, how to build your first Cosmos app, what are the basic steps you have to take care of there. And how to interact with the ecosystem. So that should be coming out sometime next month. So please look forward to that. And we'll also try to, of course, translate this into Chinese as well. Yeah, so thank you very much for listening to me. I hope you enjoyed this. Yeah. If you have questions, reach me over here. Those are my research interests if you want to talk to me about some random crap. Thank you very much. And questions. Are there any questions right now from the audience? Okay, then I'll check. Is there something on WeChat that should tackle? For mobile banking, is the validator set changed? No, but the thing is, when the mobile client comes online for the first time, it's presented with an initial validator hash, which represents the initial validator set. So what you, from a user perspective, have to make sure is that the user has some out-of-band way to verify this validator hash, so that they know that they're actually talking to an honest client. Because all the future security lies in the fact that you know, like that you can identify the correct validator set. No, validators will not be able to validate physical assets, I think. It seems interesting though. For an Asian hub with Asian zones as Zone 1, how does the hub communicate to other hubs around the world? To another zone or another hub. So the way it works is that, let's say I'm Zone 1, I talk to the Asian hub, and then from the Asian hub you talk to the European hub, and from the European hub you then talk to the zone. So it's like a multi-hop process, where you go from like server to server to server until you reach your final destination. So if you want to develop the IBC implementation, that is currently within our Basecoin repo. We're also reading repos. Originally Weave was called Basecoin. Sorry for the confusion. We're changing names. I won't have time to show you today, but IBC is implemented on top of Basecoin or Weave. So if you're interested, do check that out. Yeah, so the question is then IBC for Stellar, Ripple, Ethereum, or any other chain that's really up to someone to build a peg zone, and then there will be. And by the way, you can run these peg zones yourself. You just have to create your own validator set or talk to the Cosmos Hub in terms of the government mechanism that Ash mentioned, so that the Cosmos validator set might be running some other peg zones as well, and then people running those pegs can earn transaction fees. So there is an economic incentive behind building extra peg zones. So actually the structure of the zones becomes a direct acyclic graph. I'm talking about the question like, currently hub zone structure is only one depth tree. It can be any arbitrary depth, but of course extra depth adds extra overhead, so it's probably not going to go too deep. Is there total amount of Cosmos tokens? Jim, do you know the total amount? Yes, that is.
It's 16.8 million.
16.8 million. So yeah, the role of the Cosmos coin in the system is the security of the system. We talked about that before. Yeah, so we also talked about communication between hubs. In terms of performance, you can expect, it depends on the application logic. So if your application logic is very easy, you're going to a very high throughput there. If your application logic is very complicated, you're going to a lower throughput there. But again, you can just add zones.
Sorry, it's 168 million, sorry.
168 million, not 16 million. They aren't necessarily, they're not atomic swaps necessarily. Yes, so it is possible to extend it to IBC packets to arbitrary data. The problem becomes on how does the hub validate this arbitrary data without understanding the application logic that generated this data, right? So we're currently researching different ways of doing this, but it's still in the very early stages and might not come out for like 2 or 3 years. We'll see. Hopefully there's a way, because that'd be really cool. Right, this also happened. All the Chinese questions I could read. I think we have covered them. Delegation. Should a zone undergo a 67% fork attack, and the hub has already synchronized both forks, how's the whole network going to handle the situation? If there's a 67% attack, it means that all bets are off, right? Because someone controls the entire network. It's like Bitcoin being controlled by 51%. In these cases, there's the governance mechanism kicks in. The governance mechanism also kicks in other times, but in these kind of extraordinary events, we also rely on out-of-band human consensus on what to do next. So if the entire network is under attack, or if the entire network broke because someone managed to get a 67% stake in the network, there will be human governance involved. And have we covered these questions? Okay. Any other last questions?
If I have a question. So first of all, so when you talk about the exchange of the asset here in the network, is there only tangible asset or intangible asset? Or here we talk about token. How about cars, books, whatever thing?
Yeah, so if you can tokenize cars, we can exchange car tokens as well.
Following this question, so think about, just now you have a very important hypothesis that the asset itself will only need to be issued by a single role. That's a very important assumption, right? So think about if it is tangible asset, right? If it's an order, or if it's a car, right? I want to register the car for one role, but I can also copy this car. I mean, when I say copy, the same plate number, but different car will be, and register that role in different role. How to do the transfer management across multiple roles? That will be very challenging problem.
I think we're going to take this later on because I think it's a more involved question that I have to think about more.
That's a real question.
The answer is every zone could have its own governance. As a matter of fact, like if you look at, initially we're going to launch with Ethereum supporting Bitcoin, right? That is itself its own governance, right? Which we're not controlling. So in the case that you're going to peg a goat into a real goat, actually, that's actually one of our interesting project, which is how do you actually create a, let's say, a real assets and then peg it to the network.
Fancy
Right.
word for that, by the way, digital
Right.
twin.
Yeah.
That's
Right.
fancy
So,
word. Which, you know,
so let's say you're a farmer and you own a crops and you want to basically create a future trading commodities. You can technically build a micro exchange, right? A micro exchange, which is perfectly makes sense because in blockchain, like in the traditional exchange, will be very expensive to build just to trade somewhere in Africa like a goat, right? But you can actually do this in Cosmos, you know, and that zone will have its own governance. Obviously, you have to come up with some ways to punish. Let's say you have only 5 goats and you want to represent like 50 goats, right? That you will have its own governance and enforcement, which is manual. So that's why it makes sense for you to create a process, an out-of-band process to, let's say, tag every goat directly before you enter it into the blockchain. So you have a one-on-one sort of peg into that one asset into the one blockchain. It's always guaranteed entry. And you can actually include that in your blockchain. So every goat would have a, let's say, for example, one of those tracker, right? And that could be inserted into blockchain, and that would be sort of like a fly trap into an amber, like it's completely frozen in the blockchain. So you can't change that, right? So anyway, so that's one of your answers.
Some more questions from the audience? Okay. Yeah, thank you very much all for coming. Harriet, do you have like last minute announcements?
Yeah, first of all, I want to thank all of our great speakers coming all the way around the world, from UK, from Germany, from US, from Korea, come here to deliver this thorough technical dive. And I hope that today give everyone a good sense of what Cosmos is. And 我刚才都忘了，他们刚才在说英文，实际上我应该给大家讲中文来着。对，这样的，其实我是感觉就是今天呢，希望大家确实像大家刚才就是我们的这个演讲嘉宾所讲的一样，希望大家从当中能够学到一些东西。然后呢，我们现在站在创新的最前沿，非常希望大家加入我们。今天的活动呢马上就要结束，但是呢，其实今天是一个刚刚一个新的开始 ，Cosmos China 中国社区今天是开启的日子。然后大家可以有多种方式加入到我们当中来。其中最重要的一件事情是，如果你有兴趣加入跨链技术的开发的话呢，第一件事可以加入到这个 Hackathon， 今天正式开启，而且是为了庆祝中国社区的开放。然后第二件事情呢，刚才也提到了，像那个Adrian 也谈到，我们有很多的一些技术的一些文档，如果大家要是有兴趣的话呢，也可以做志愿者，然后来帮助我们一块儿来翻译这些文档，让中国社区能够更好的接触到这样的技术。当然了，我们也会有礼物可以发给大家，包括 Atom 啊或者这一类的一些cryptocurrency。然后第三个呢，我们也希望呢有更多的一些程序员 developer 能够加入我们。我们很快也会要进行一些开发团队的一些招募，我们很有可能会在上海还有在杭州都会设立开发团队。如果有兴趣的，希望大家能够关注我们的公众号，然后能够加入到我们的这个 WeChat 的这一个社群里面来，积极的贡献你的一些想法，然后加入到这儿来一块儿进行开发，一块儿加入 Hackathon， 我们大家一起来推进这个创新的全员。好，谢谢大家。然后大家呢还可以呢在这儿就是吃些东西，然后如果还有问题的话，我们的这几个嘉宾还会在这儿有一些时间，然后大家自己也可以互相聊聊交朋友。好的，好，谢谢。